So welcome back. Last video we talked about Kw and the equilibrium law expression, looking at the ratio of your products, the ions associated to the reactants. And now we'll look at a question related to Kw. So here's a question. If the H3O, which is your hydronium ion, in nitric acid solution is this, what is the OH concentration, hydroxide concentration? So then before we begin, then we have to think about what is nitric acid. What's the formula? And nitric acid is your HNO3, your nitrate with a proton attached to it. And since this is going to solution into water, you can write it in two ways, right? You can have your hydronium ion, which means that this H gets donated into your H2O. That gives you a hydronium ion, leaving you with this negative anion of nitrate. And what the question is saying is that you actually have a concentration of hydronium ion of 0.0020. So then the question is asking, well, what's the hydroxide ion? Remember, this is still in water solution, and water can be dissociated into your hydronium ion and also OH negative. And somewhere in this solution also contains your nitrate, NO3 minus. Excuse me. So then the question is, well, how do we calculate this? What is my hydroxide ion? Well, we know what my Kw is, which is 1.0 times 10 to the negative 14, a very small number. We know the concentration of your hydronium ion, which is your 0.002 molar. And then we are trying to find the OH, so I'm just going to leave my hydroxide here. And once that you punch this in and calculate this, let me put this in the calculator, negative 14 divided by 0.002, you get an answer of, so this is my OH negative, is equal to 5 times 10 to the negative 12, and this is concentration, so I should have molarity or moles per liter. So what does this number represent? So that means that when nitric acid is in solution, you're going to have your NO3, and you're also going to have an OH, and you also have your hydronium, because that's your water dissociating. But you can see that the concentration of OH is actually a lot smaller than your H3O. That means that, here, let me just kind of write this. This is negative 12, and then H3O is 0.002 molar. You can see that this OH concentration is a lot smaller. That means that that's why nitric acid is a really strong acid, because there's so much of this compared to the amount of OH concentration. Remember, what makes an acid acid really is the presence of this hydronium ion on a proton, right? That's your Arrhenius's definition. Right, so if you have a lot of this, it makes your acid quite strong, whereas your OH is actually very small. So you can calculate the pH of this. Alright, so let's try a second question. If you want to just pause this and give this a try. Alright, so 5 grams of calcium hydroxide is dissolved in 500 ml of solution. Write the dissociation equation and calculate both the H3O plus and the OH minus. Let's write calcium hydroxide has this formula. It's going to get dissociated. I'm just going to put it into like this form. 2 plus, here's my AQ, 2 OH minus AQ. So dissociating to these two ions. I know that I have 5 grams. So remember, if you have grams, let's just quickly convert this to moles. So grams at the bottom and then moles at the top. From this grams here, I need the molar mass. So calcium, I need 2 oxygens and 2 hydrogens. So I'm going to just round all these numbers. I think calcium has a molar mass about 39.98. So let's round it to 40. Oxygen has 16, hydrogen has 1, but these all have to be multiplied by 2. So this is 32. 2. So let's add all these numbers together. So you should get 74 grams per mole. So I totally rounded all those numbers. So that's my setup to find moles. Let's punch in my calculator. 5 divided by 74. So I have 0.0676 moles. That's my calcium hydroxide. I'm going to cancel out my units. Okay, so then what I need to do is that I need to now put this into molarity, right? Because I have a volume here in 500 mLs. So what I need to do is, let me just kind of move this down a little bit. So I'm going to take this 0.0676 moles and I'm going to divide it by 0.5 liters. So where's this liters from? I converted this milliliters by moving the decimal place 3 times to the left to get liters. So let's get my molarity because we're working with concentration here. So that divide by 0.5 and my answer is 0.135 molar. This is CaOH2. So now we know what we're working with. So then what are we going to do now with this? So I'm just going to rewrite this equation out. So OH2 dissociates into Ca. I'm not even going to bother with my aqueous. I know you guys know what I'm talking about. Now I know the concentration of calcium hydroxide that I have. Do I know the concentration of Ca? Do I know the concentration OH? Well, I can, because I can actually use my stoichiometry and find mole-to-mole ratio for this. So if you look at it, check if my reaction is balanced. It looks like it's balanced. So then this is going to be 1 to 1 to 2. So I know that the calcium ion concentration is going to be the same. But this one is a 1 to 2. That means that there's 1 of this for 2 of this. So I need to multiply this by 2 to get to here. So I'm going to get 270 molar of hydroxide ions. So really, when you were if you were to look at this, when you put a CaOH2 into solution, yeah, this makes sense because you actually will get a actually 2 hydroxide ions for every 1 calcium ion, right? That makes sense. That's why we multiply this by 2. So then once we have, so this is the first answer. OH negative is my 0.27 molar. Now how do I find my hydronium ion? Well, I can use my Kw because Kw again is my H3O plus hydronium times hydroxide. I know that K is my constant. It's always going to be times 10 to the negative 14. I know my hydroxide is 0.270. So then let's find my hydronium ion. So let's do the math here, and let me punch it in the calculator. Divide by 0.270. So then my answer here is 3.7 times 10 to the negative 14 molar. So make sense out of this number. This is a really small number, and it's for hydronium. So is this an acidic or basic solution? Well, it's going to be a very basic, because this number is a very small number, and you can see the hydroxide ion is very large. So this one is large for hydroxide, which makes it a basic. So that's whenever after you calculate, don't forget to make sense out of your number. So just to verify and double check your calculations and if it made sense. All right. So that's how you use the Kw to solve for your OH hydroxide ion or your hydronium ion. And after this, the next part is how do we calculate the pH. So hopefully that video has helped you. Thanks for watching.